Gas turbines are a key technology in the power and aviation industries. Inside a turbine, high pressures, tremendous centrifugal forces, and high temperatures prevail. The rotating blades inside a gas turbine must withstand extreme conditions. At full power, the blades rotate at 1,000 miles per hour and are subject to loads of 11 tons, which is about the weight of a fully loaded London double-decker bus. Manufacturing gas turbine blades has always been one of the most challenging tasks for engineers. Not only do the blades have to be strong, but they also are riddled with cooling channels that make them difficult and time-consuming to manufacture.
The casting of turbine blades requires complex mold construction before each blade can be individually cast, a complex, time-consuming, and costly procedure. Engineers at Siemens have been developing an alternative method for making these blades, using additive manufacturing. Additive manufacturing involves applying one thin layer of material after another to build up a shape, working off a CAD file. The Siemens team printed their blade using a powerful laser beam to selectively melt a powder made up of a high-temperature resistant powdered polycrystalline nickel-based superalloy.
The core project teams were multinational groups of Siemens experts and material solutions engineers in England, Germany, and Sweden. They tested the blades at a Siemens test center in Lincoln, Great Britain. The blades survived operating conditions of 2,000 degrees Fahrenheit and 1,000 miles per hour. It was the first time that blades entirely produced using additive manufacturing had survived such conditions.
This is a groundbreaking success for the use of additive manufacturing and promises to accelerate the design cycle for new gas turbines. Siemens engineers say their process can shorten the design to production time from 2 years to 2 months, reducing lead time by up to 90%.